All right, good morning, everyone, or good evening, depending on from where you join. So today we are looking at our async awaitables proposal for the third time, I think, hopefully the final time. And then it's a bunch of more API reviews. So, oopsie, I just So can we even implement them effectively or efficiently on value task and value task of T?
One. I didn't do that in the implementation because it didn't seem worth all the extra code and complexity.
And this isn't going to introduce a release or you've completed the value task, so the source is refreshed problem.
It doesn't have that problem, but it means basically once you use wait async on a value task, you can't touch the value task again. which is the reason why adding it is a little. I just realized in my write-up it should be struct value task, not class value task. But that's the reason why it's not necessarily a slam dunk, because if you did want to go back to using it, you can't.
I should say also that this happens regardless of whether you end up awaiting the resultant value task. You just are unable to touch it at all.
Yeah. So why don't we start with just the task? How do people feel about switching from the configure await to wait async?
It looks good to me. My only concern would be just, are we comfortable with the perf implications here? And the only other feedback I would have is, I'm just looking at the existing task.wait method. It's got a slightly random set of overloads. Do we want to mimic those or not?
Right. The randomness you referred to is in part that it also has overloads that take int timeout or int milliseconds timeout.
Yeah.
I think it only has. I don't remember now. I think it only has that for like the one that just takes a timeout, but it doesn't for the one that also takes a cancellation token, or maybe I'm misremembering.
It's actually the other way around. It has wait int32, wait time span, wait cancellation token, and wait int32, cancellation token.
Got it. Okay. I knew there was we were missing one.
Yeah, so the weird thing is it's missing what seems like the most complete one, which would be, time span, cancellation token.
Right. So I honestly don't have a strong opinion about whether we have an int overload or two int overloads here. I didn't include them just because I know there's been feedback in the past about not liking the fact that we have this raw int without a unit associated with it. But if people want to add it, I'm totally fine with that.
I would leave the int ones out, personally.
Yeah.
So just do time span unless there's a lot of complaint. But time span that from milliseconds is not very expensive.
So one question I have is, so this one is effectively producing a new task that has different configuration on it or something. Is that more overhead than the configure await would have been?
No. I mean, maybe by a few bytes if we really wanted to eke out perf, but the configure await still needs to allocate some object to coordinate between the task completing, the cancellation token completing, being canceled, and the time span timing out. I have a hard time imagining a scenario where it wouldn't need that extra object. Now, maybe you could do something like pooling that object if you wanted to, but I think any implementation we would go with for the foreseeable future would basically just have this method under the covers.
And is a completed task going to return this?
A completed task will return this, as will wait async called with an infinite timeout and a non-cancelable token.
How are we defining infinity in this case?
Timeout.infinite timespan.
Fair enough.
Obviously. No, that makes sense to me. So the last time when we talked about this whole configure await thing, one concern people raised was that this is too discoverable. Do we think this is worse, better, or about the same?
I think it's probably about the same.
I honestly would have said the same thing, because you're effectively having to call some method on before you actually await it. So it will look virtually identical in IntelliSense. I mean, you could argue that configure await is the uglier version of this here, but I feel like discoverability-wise it's the same, because you just do dot and things show up in IntelliSense or not. I personally like this design more.
My hope as well. There was a question earlier about efficiency. my hope as well is that these methods are the rare, are the minority use case. Like, ideally, you don't need these because the APIs that you're using take a cancellation token, right? For example. These are only used if you're trying to wait on something that doesn't support these concepts. And so my hope is these aren't showing up on, really core critical hot paths.
And this also solves you don't want the throw to happen, right? Because you could await the wait and then ask if the state's faulted.
Yeah, I mean, if we were to add a custom awaiter that suppressed the throw, then it would work with this like it would with any task.
I guess if wait async is returning this, then if it's true, you would still get the exception.
Yeah, I mean, the return task will still store an exception in the same cases that the original task would store an exception, or an exception due to the timeout of the cancellation token. But
right,
any extension configure await like method that was meant to suppress the exception actually being thrown would work with this just fine. Whereas with the configure await approach, it would have had to have been written as an extension on configured awaiters.
Right. Yeah, I was had a brief moment of that the two tasks were independent, and so that what you had was a task representing the wait, and then that you had to go back to the original task for the result. But that's not the case because you already discussed that it returns this. So
right.
Don't mind me.
I call this out in the discussion below. The main interesting way that these end up differing from the existing wait methods on task, other than the fact that these are asynchronous versus synchronous, or returning a task versus blocking, is that the existing wait methods for timeouts return a bool and use the bool to indicate whether the wait timed out or not. But that's weird here. To try and propagate here is weird, because then the wait async method ends up needing to return a task of bool, which is very confusing if you are on a task of bool, for example. We could return a task of bool comma t result, but that's harder to consume. So I'm suggesting it just be, the original plan, just like the configure awaited throws for a timeout, but I'm open to suggestions.
Wait, it throws for timeout?
Yeah.
What kind of error? A timeout exception?
Timeout exception, yeah. Unless we have a better solution in mind.
I'm thinking. So I guess the typical case before this would be a task when any, right? And you would just check the task itself and see if it was the other one.
Right. Now, most of those cases then end up throwing an exception at the call site, at least the ones that I've seen.
Right.
But there are you can certainly imagine cases where that's not true. Like a polling loop or something.
Yeah. You could do task of bool.
Yeah, people will totally figure that out.
I'm still scratching my head.
Presumably it returns null if the inner task didn't complete.
Yeah, I feel like if this was something if we cared about, then we would revisit support for a no throw await, and you'd still be paying for the timeout exception allocation, but not for it to be thrown.
Yeah, I mean, you can. Is accessing the wait handles off of tasks a no-no?
Yes.
Why do you ask?
Well, because you could just timeout wait the wait handle and then ask if it's in the faulted state and then move on with life.
Well, you can you can synchronously dot wait on a task as well.
Oh, we don't have async interaction with the
No.
wait handle? Okay.
I mean, you could register it with the thread pool. Thread pool is a register method that you pass it a wait handle, and then it does the synchronous wait kind of in aggregate on one of its threads and calls you back when it is set, but it's not pretty.
Yeah. I mean, if the scenario that we're trying to tackle is just I have an async operation that doesn't take a timeout, including that, it was already in progress when it came to me, and I'm only willing to wait for so long, like, this seems fine. Like, it solves that scenario. It doesn't help a lot with the I want to avoid the expense of try, catch, ignore, but...
Well, no, but my thinking is if you want to avoid the try, catch, ignore expense, which is a reasonable thing to want to do, then we need to revisit separately from this a suppress throw mechanism for awaiting.
Sounds like
And that would apply to any task, not just these. What, Ema?
That sounds like configure wait again.
Yeah, it would be a separate, rather than baking cancellation token and time span into the awaiter, you would have .wait async with the token and the timeout, and then some configuring await thing, either explicitly named for suppression of throws or configure await that takes an enum with the behavior, or we'd be back to that discussion about controlling the actual await, whereas these were really controlling things that can only be done via the await, whereas these are things that can be done not just for awaits.
Right, which sounds like it's an orthogonal problem, in which case we could just, solve this one here first and then revisit the other one later if we wanted to.
Exactly. So I will probably actually go and reopen that issue, because we closed it because we wrapped it into this one, and then we cut it from this one, so we should reopen that one.
Yep, that seems right.
All right, so what I'm hearing is the task and task of T result ones look good as is.
Yeah, the value task ones bother me.
Can you explain why?
Because until we see how people end up using this in practice, like I'm concerned that we're adding yet another this invalidates the value task. Please don't touch the original input again. The fact that this is returning the this in some cases means hopefully people won't ever go back and look at the previous task, but it's a concern because with the power that comes with value task completion source is the danger that it gets touched twice. And
also, you can basically achieve exactly what our implementation does in 2 lines without these methods. So at the moment, unless we choose to do that further optimization for iValue task source, they are largely convenience overloads. Also, value task doesn't have wait methods today, whereas task does.
So the user is forced to do add task.wait?
Yeah, that would be, if we didn't have these and they wanted to wait on a value task with a cancellation token time span, they would need to as task. And if they cared about eking out perf, they would probably first have that's one of the 2 lines I mentioned. The other line would be if not completed.
Yeah. That seems fine.
yeah, because as task is already on the, you should know that this invalidates the value task. Please stop talking about it.
All right. In the name of making forward progress, because I haven't heard anyone strongly argue for these, why don't we just go with the top 6 methods, and we can always revisit adding them to value task later if we really want, but I don't think we'll want.
Good with me.
Yep, like that.
Works for me. So we basically said we will cut it because there's this additional complexity of accidentally touching it twice.
Additional complexity of actually using it twice. one of the arguments for wait async was there's already wait methods, and those don't exist on value task. Implementation-wise, they're really just convenience methods, whereas the ones on task are, 100 lines of code or something, whereas the ones on value task are 1 or 2 lines of code.
Works for me. All right, so then anything else to add? Otherwise, this is it. It's funny how this thing went smaller and smaller.
Thank you all for entertaining our multiple meetings.
I mean, there's that famous Mark Twain quote of, sorry, but I didn't have the time to write something smaller. It takes time to slim things down.
That is true. All right, so then this is the one, and now that Fowler is clearly on the call, let's fast forward to his issues. I think this was the first one, and let me actually refresh the page now that I'm signed in again. We don't have to get blind. All right, David, talk about this one, or Miriam, depending on who wants to talk about this.
I can, I guess. Is Miriam here? Nope. This was just inspired by, today we have an API, so history. We have the web host and the generic host. The generic host was to replace the web host. So a bunch of options that existed on the web host, like specifying things like a shutdown timeout, were more first class, and extension methods on the web host builder. In the generic host, we want to make it a bit more generic for configuring host options. So we added this host options type, but we never made it convenient to use. So you have to kind of use this super weird configure services, then configure, then set options. So the goal here is to add a shortcut to configure the host options top level, so you don't have to actually do this nesting. That's hard to find and discover. If you scroll down a little bit, you'll see a sample like before and after. Yeah, there. So you get IntelliSense, and you can see, like, configure host options, and we can add a bunch of options to this type. The web host used to have a use timeout for the top level. Things that were deemed super common, we put as a top level function. But I think having one is enough to make it discoverable.
Yeah, I mean, that makes sense to me. I mean, seems certainly more discoverable than configure services. Yeah, it's kind of crap today. I think I would have never found it. No one does actually. So it seems pretty straightforward then.
Yeah, I was on the YouTube link rather today.
Oh, sorry. So what's your opinion on this?
No, I just listened in, and so same thing. It's just as you said, it would have never been used otherwise. But yeah, I have nothing else to add.
So then we just accept it as is, or does anybody have any dissenting views?
It's perfect.
I take it that means no. So then let me mark this guy. All right, first one down.
Awesome.
Oh, this one is controversial. I remember this one.
Oh, good. The good one.
All right, take it away.
So I think the last time this came in review, I wasn't here. I think Stefan tried to argue for it. The intent here is basically, so the scenario is I basically don't want to allocate a buffer until the underlying stream has data. The pattern is very common in networking applications to avoid allocating buffers that just sit there pinned for a long time in memory. So the typical trick is you pass in a byte array that's empty, and that hangs for and then when that returns, then you can do a second read to get the actual information. The stream pipe reader reads on the user's behalf and allocates buffers internally. So the intent here was to have a bool to let the caller configure if it wants to do a 0-byte read first to wait to avoid having the buffer be allocated internally before doing the allocation. And I think there was not confusion, there was controversy around the fact that potentially some streams don't support 0-byte reads. And I guess support in this case means it would throw, but that seems rare. And I think for the most part, they're kind of, well, I think Stephen Toll actually wrote a pretty good thing on this on a different issue, where they're kind of three kinds of streams. Ones that are connected, ones that aren't connected, and ones that wrap other streams. The ones that are connected, like pipe stream, network stream, etc., basically do support these semantics. The ones that wrap just have to delegate to the underlying stream, and then the ones that don't just return 0 without the wait. So in all three cases, there's kind of no downside to supporting that pattern.
Well, this is opt-in, right? The default is false.
Correct.
So if you turn it on and something goes weird, there's an easy workaround, which is don't turn it on.
Right.
Yeah, I think the feature is fine. The only feedback I'd have is wait for data is not a super descriptive name.
I was going to have the exact same feedback. It's something like, delay, I don't, not these words, but delay allocation until data available or something long and terrible.
Man, y'all are the reason that our stuff is verbose.
We are. The problem for me with wait for data is I feel like that could apply to, it's ambiguous and could apply to other things. Like, if this is false and I call read async, does that mean it's going to return immediately?
Yeah, that's kind of what I would, like, what does it mean to not wait for data? You always got to wait for data, right?
So any name suggestions that aren't, like, terrible?
Public bool, ask David what this is.
Well, I mean, can you come up with a verb for 0-byte read? Like, what are you doing? This polling the stream?
No, I mean, it calls read once, right? And if it returns immediately, then it will just read afterwards. The assumption is that if the read returns, that there's data. So I guess you could call it wait. I guess we could add more stuff.
Could we be very literal? Use 0-byte reads?
Yeah. That seems fine.
Yeah, the problem with 0-byte reads in stream is technically if a 0-byte read ever completes, the stream is, according to API documentation, now complete, and there will be no further data.
Yep.
But those docs are just wrong, because if you pass in 0, like, what else are you going to do?
A&E, or sorry, not because it's not null. Argument exception.
Literally, none of them throw.
Yeah.
So last time
really, the only other concern would be if you have a stream that they put outflow logic on read that said if it's 0, then call dispose on themselves. Again, seems unlikely, but it matches the behavior of the documentation.
Yeah, I mean, I think if that's actually what the docs say, the docs are just wrong. We need to fix the docs.
Well, it just says if it returns 0, it's end of stream.
Right. If they don't clarify it, we should fix the docs to clarify, except when 0 was passed in.
Yeah.
So what I'm hearing is, so last time we suggested add a new method on stream, like wait for data async or something, and what I'm hearing is we wouldn't do that, we would just change the docs to say support 0-byte reads.
Yes.
Yeah, and change the bool here to be 0-byte read. Use 0-byte reads.
I'm fine with that name. I would, if you want something slightly more descriptive, you could say delay allocation until data available.
Nice. Jesus, delay allocation. Delay alloc is fine. Delay.
Or defer alloc. I don't know.
I think it's, use 0-byte reads. It's descriptive of what it's doing, why there may be a problem, and anything else that we feel like adding behind that flag is now possible, versus if something else was solved by the same solution, we need a new name for it.
Okay. The name I could ask about. So yeah, so I think that's fine. Awesome. All good?
Yeah.
One question on the name.
Yeah.
Sorry. I know I suggested it, but the prefix use, I wonder if we should change that to like allow or prefer or something, or can we guarantee that if this is true, we will always use 0-byte reads?
No, I think prefer. So it only does it if it doesn't have a buffer ready. So maybe prefer is better.
Permit, yeah.
Jesus, do we use permit anywhere else? I don't think so.
Oh, CADs.
I don't like permit.
Honestly, I think use is fine. To me, use doesn't imply you force it everywhere, right? It just means you use it as a mechanism, right? It doesn't mean you're not prescribing it everywhere, right? You're not saying must use 0-byte reads, right?
Okay,
that's fine. I don't have a high care. I just want to make sure we weren't locking ourselves into something.
Because the problem with allow is it could sound like you're asking whether someone is allowed to call into the stream pipe reader to do a 0-byte read, instead of that you're describing what it wants to do to the stream on the other side of it.
Right.
That's actually a good question, David. What happens if on a pipe reader you do a 0-byte read?
So today what do you mean? Today when you use pipes, you don't pass a buffer in at all.
But no, don't you pass a number?
No.
You just say read async?
Yeah.
Okay.
You get what you get.
And it gives you back a memory or something?
Yeah.
Yeah, okay. Ship it.
Yep.
I will fix my PR.
All right, then there's this one down.
Man, this is fast today. Efficient.
We try to please. Modern timer API. So this is the really controversial one.
Yeah, I changed it like 4 times after, like, in the last, I think, week or so. I think I landed on async timer. And there's still kind of one thing that we should figure out after this whole thing. So I guess starting from the beginning, timer has a couple of issues, quirks, I guess, that are there in the 1 to 4 listed out, with how it routes itself, with how timer callbacks can overlap. Actually, David Keane this morning replied to an email thread where he fixed a bunch of timer overlapping issues in VS by calling change when the timer callback ran. What's the other one? Yes, timer callbacks aren't asynchronous, so today people assume that you have to block in them to kind of do work. I've seen that in a couple of cases. So the intent here is that once you have an API that takes a callback, you end up needing a sync and an async callback overload, just so that consumers understand that they can use either and be fine. So that the fix is to basically expose a model that doesn't have a callback, that is more that you have to await. And I think where I landed with that is an async timer that basically converts the timer callback that you typically have in the constructor. Instead of doing that, you await this wait for next tick method, and it will just yield whenever the period has passed. There are two options for this. There's if you are currently running the continuation and other ticks kind of fire along that time, the next time you wait, should it finish immediately or should it wait for the next tick? Basically, if you miss ticks, do you get to observe them or are they skipped? I think that could be an option. It's kind of left out here, but I think you kind of want to support both models. Does that make sense?
There's actually sort of three models, right? There's, let's say you miss 7 ticks. Do you the next time you go back, do you immediately get notified and that consumes all 7? Do you immediately get notified and that consumes just one of the 7?
One. Got it.
Or does the timer not reinitiate itself to launch the next period until you call wait for next tick?
Right. Fair. Okay, 3 modes.
Well, and then there's the question of, is the period the time between ticks or the delay between completion and the next tick?
Right, and I think the mode controls that too, right? So if we want to support all 3 models, then we'd need an enum or something in the constructor. But I want to start simple.
Which mode do you think the simple one is?
I think the simplest one is you ignore things that were missed while you're running, and you trigger the next period once you call wait again.
Right. So if the period was 1 second, and I get notified, and then 10 seconds later I call wait for next tick async, then I still end up waiting for 1 second.
Right.
Okay.
See, I would have expected that it would tick immediately. Like if I'm cleaning stuff up, if it took me 10 seconds to clean the last set of stuff up, or if I just got stuck on one or something like that, then if 10 seconds have expired, I'd want to go initiate another cleanup immediately.
Yeah, like I was going to use 5 minutes and say the completion took 5 minutes and 0.1 seconds. I think that many people looking at their logs would be like, the timer didn't fire, as opposed to, oh, I understand, I hit a skip point.
So today, when you do this, and the timer takes a long time, they fire in parallel.
Right. So when I've had to do the thing Dave Keene was talking about, of in the callback, you basically cancel the timer, do a bunch of work, and then resume the timer at the end. I feel that the ones that I worked on, we always did if I took longer than the period, tell it to fire again immediately. And otherwise, we did try and make it so that that it was really an every 5 minutes or whatever timer. So subtract the amount of time that we think that we spent doing this work.
Right. The one that I've seen the most common is you change to infinite when you start the tick callback, and then you resume it after it finishes. I haven't seen the subtraction used in people's code bases often.
How is this going to integrate with, say, WPF or WinForms, which typically use the WM timer setup instead?
How does timer interact with those systems?
They use they use the other timer that's based off of WM time.
They should keep doing that then. Yeah, this doesn't have any specific integration with that. The only benefit that I see, I mean, does the same context help there at all? or is that just like you need a different timer implementation that kind of is built into the event loop in Windows?
Yeah, it's that they use a different one. It's why we've got like 3 timers already today in .NET. You've got system timers timer, system threading timer, and there's another timer somewhere, and this one's going to be adding a 4th one.
There's more than that.
Yeah, I was going to say it's more than that.
Yeah.
Yeah, so system timers timer is just a wrapper around system threading timer that adds some integration with basically synchronization context, allows you to specify it explicitly. There's system Windows Forms timer that allows you to put, or a component model timer, or something that allows you to put one onto a Windows Forms form. This WPF has a dispatcher timer. They all end up wrapping threading timer under the covers.
Okay, so should we go through the usage and then the samples, and then we can discuss what we think the default should be? Like, should it be the skipping, the 3 modes basically? Yeah, sound good? Okay, scroll down. All right. Pretty simple usage, and this kind of shows 2 models. One, we were kind of in an async method that doing a loop over and over. There was a question about why not just use task delay, and I think if we do support the different modes, that having a single type do multiple things would be kind of nice. But yeah, it's pretty simple usage. You do a loop, and you wait for next async, and it returns task of bool, which is interesting, because it avoids you having to write that while true logic, which I think is gross. And I guess the question is, how do you stop the loop from running in this case? And I guess there's 2 modes that exist today. You can either call stop async, which is the thing I added, that makes the bool return from wait for next async return false, or you can pass in a cancellation token. And have it 0.
So David, in your first usage sample here, this is functionally equivalent to just doing while true await task dot delay 1000, yep. Right? Okay.
Yep. It is.
Assuming that was the mode, that was the default.
Right. Yep. With less allocations.
Yeah, this isn't a pro or con against, a reason not to ship it, but for 1 second delays, I'm not particularly concerned about allocations.
What? Yeah, I know. One other thing about the pattern here for usage is that I think is a big deal. Typically, when you have timers that fire with a callback, you have to figure out the disposal, and it ends up being a bit tricky. In this model, you kind of dispose naturally where the timer is used. So you can see that the await using var timer equals async timer blah, and the call to cancel or stop will halt the loop, but the timer gets disposed where it's being consumed. So you never have a case where you're trying to use the timer in the callback where it's being fired, but a different thread calls dispose at the same time. So different threads call stop or cancel, but never call dispose, because dispose is always called by the consumer. So you never end up in a case where you're trying to access a dispose timer in your callback, if that makes sense.
Stephen, I had a question. How much time would you consider to be little enough time for allocations to matter?
I mean, if you only had one of these going at a time, I don't think you could pass a value to. We don't allow you to express a small enough number of milliseconds that it would matter.
Right, and anything below 16 milliseconds is going to be iffy anyways, because the thread schedulers for the OS is about 16 milliseconds. So
right. Where it
Not
could
on
matter
Linux,
is if you weren't just doing one of these at a time, but you were doing a million of these at a time. Then I'd rather have a million async timers allocated once for the lifetime of the whatever than a million timers once a millisecond or once every 15 milliseconds.
Do you think that there'd actually be that many in practice in any kind of actual scenario?
Nope.
I'm finding because I'm struggling seeing the actual like thread pool that's got to behind the scenes keep track of the timers like system threading timer does.
You know where it happens? In
actually keeping track of all of that and the state up to date.
So the way this happens today in practice by mistake is we end up building libraries that basically have a timer embedded in them, and they get used on servers and clients. So one example is WebSockets. If you turn on to keep live in WebSockets, it creates a timer per WebSocket. When you have a lot of concurrent WebSockets on a single server, up to 1 million, you end up with 1 million timer entries by default if you don't turn off the keep alive. That's not a good thing, but
you shouldn't have 1 million timer entries there. You've got 1 million timer instances, but those wrap the timer queue, which is no more than the number of threads you have on your CPU. Like the timer itself wraps this other concept that's actually done on a per thread basis.
What does that have to do with anything?
I mean, you'd still have 1 million instances of the async timer class here.
Yeah. Getting added and removed
Right. So I'm not seeing what benefit this has other than avoiding the additional task creation, which seems like you could pool that or something to handle the case.
I don't think this is about perf. The allocation thing only came up because I thought a separate issue about allocations, and it's kind of a inside joke, but the API isn't about allocation performance, it's about usage patterns.
I think the allocation is against calling task.delay, where every individual call to delay is going to return a new task.
Right. Exactly. And you can't pool those.
Could we not have a specific like task delay pool, something that's specifically for delaying tasks on a per thread basis? I
mean, honestly, I don't think the main value, this gets back to the modes, I don't think the main value of this API is for the case where you actually want the while true await task.delay semantics. The main value of this API is for where you want to be able to be notified of a next tick that started the moment the previous tick fired. Because that helps avoid the usage problems of I'm running the response and now another handler for it is running in parallel to me. And how do you deal with those, overlapping things? This type would help to avoid that with this usage consumption because there's no way to have multiple running in parallel because it's just one sequential async loop.
Right. That is a vote for the second mode?
Either second or third, first or I don't remember what the numbers were. It's a vote for the one that is for the mode being defaulting to keeping track to starting the period immediately.
Right.
Whether or not it keeps track of how many times it's fired, or whether it only keeps track of whether it has fired.
Right.
Yeah. Yeah, like if this is something like akin to garbage collection, right? So you're moving over your temp files or compacting some storage or whatever. You wouldn't want it to just fire 7 times in a row if one of your things took 7 times longer than it should have. So I would say that the default mode would be that it has the bit of the timer has already gone off, and that the wait for next tick async completes immediately without waiting when that bit is set, and that it tries to basically it tries to be a metronome, and it just tells you has a click happened since you last did something.
Especially, and we can define the APIs, but if that's the default, then we also have the stop method. Like you could get the don't start the period until I call wait for next tick async semantics by calling stop immediately after you await.
Yep, that's true.
Yeah, I mean, you'd have to have resume.
Yeah, well, if
Should this basically mirror how event wait handle works, except with async then? Because it sounds like that's the three modes we want, is basically what event wait handle does, but with a proper await support, whereas waitable timer doesn't have that.
For those who don't, yeah.
Enlighten us, please, Tanner.
Well, like event wait handle has auto reset event, manual reset event, and waitable timer. And the purpose of these things are you want to have a thing that you can await, and you either want it to auto reset so that it immediately starts, it immediately becomes available for polling again, or you want to manually reset it and say, I don't want you to become blocked for triggering. I don't want you to receive the next tick until I tell you you can.
I see.
And
yeah,
so
I'm not sure these map. I understand what you're saying, and it's an interesting comparison. I don't know that these map directly because the manual one for me would be akin to saying, don't start your next period until I take some explicit action. And the auto one would be akin, like, either calling resume or something. And the auto one would be akin to saying automatically start it again the next time I call wait for next tick async. Both of those would seem to miss the keep track of whether there's been something that's happened in the interim and complete automatically and then sort of reset.
I would have taken the auto one because it works just like, so with the auto one today, if you, as soon as you've triggered the wait, it resets itself back to be triggered again. And so I would take that as soon as you call a wait, it resets itself to let's start waiting for the next set to happen.
Yeah, that sounds familiar,
Yeah.
and I think that's why I always use manual, because
No, and I know
the
I know
auto
that's
causes the
behavior.
double fire.
I'm having trouble. I understand what you're saying, and I know that's how it works. I'm having trouble mapping it to how I would use this method.
Well, the trigger is just the tick happening. You've got something that's going and saying, this is fired, so now the await can be completed. And that just happens to be the tick.
Oh, you're just saying, okay, you're just saying, like, imagine async timer had a bool that was passed to it to say whether it was the manual or auto. And you're mapping manual and auto to two of the three modes that we discussed earlier.
Yeah, because that's my understanding of it from what we've discussed.
Sure.
So just so I'm clear, we think the first mode is not as valuable, and because tactically works for that mode, we can have a bool to specify if we want mode 2 or 3. And mode 2 or 3 are basically, I think 2 is if n ticks fire, I want to observe n yields, and if n ticks fire, and mode 3 is if n ticks fire, I want to observe one of those.
So that would be valid. I don't think that's what Tanner was saying. I think the bool that Tanner was describing was between the. All right, so we actually need to number these correctly.
Yeah, I mean, I don't think it will be a Boolean. I think it'll be an enum, because we've already talked about more than two.
Yeah, I know. Yeah.
Right.
Okay.
But I think that if you map the manual reset to the one where the period doesn't start again until I call wait for next tick, and you map the auto reset to one that only stores a bool for whether it has ticked in the interim or not, then there is
Right.
still the third mode of ref counting how many times it has ticked.
Right.
Right. The third mode is basically, I guess it's basically auto, but instead it doesn't stop once one happens. It doesn't just change it from false to true. It changes it from 0 to 1 and then increments it every time it gets set. That way you can track how many times it's occurred.
Right. And I think, in my mind, the first mode, the one where it resets, it starts again the moment you call wait for next tick async. Like that's when the period ticks off. There's value in that, but I'm not sure there's enough value over wait task.delay for it to be worthwhile. I think the second case where it is just false or true is probably the predominant use case. And I could imagine use cases for the third, but I think they're probably the minority.
Yeah.
David, do you have something like this in the ASP.NET code base today?
Yeah.
And which mode do you use?
The mode where the second one, where if it fired while running, it'll treat it as it'll observe that tick the next time someone calls wait. So it'll finish immediately if you did wait for next tick and the period passed.
But if it fired 3 times while you were doing something else, when you came back, you only get 1.
Yeah.
Yeah. Right.
Yep.
This is kind of a weird reference, but JavaScript has set interval that is very, very commonly used. It's used for UI, so that's different, but I do wonder what it does when ticks are skipped. Of course, it would be weird for ticks to be skipped in JavaScript. Well, not necessarily weird, but not common, but it certainly could happen.
I would expect in most UI scenarios it's used for things like animation, in which case you typically care about the delta between the first call and the last call. That way you can interpolate exactly what the update should be.
Yes, that's true too. It is used in scenarios like Node.js as well, though, or at least could be. I don't know how much it is in practice.
It's a lot, actually. Only thing is, in JavaScript, you can't really block in the callback, so you would have to do something that took a long enough time for the interval to fire again, which is kind of tough.
Just count to a trillion.
Might get yielded. I'm trying in the browser.
So does there actually need to be 3 modes and not 2? Where, because it sounds like the third mode, it sounds like the 2 modes are the auto, the manual, and then this third mode is really just ref counting how many times it's triggered, which you could imagine just happens automatically in any scenario. And there's the method for reset has an option for, do I reset back to 0 or do I decrement by 1?
Wait, who's calling reset?
That would be the manual case, right? Basically saying I'm ready to take a tick again.
I thought there was no reset. It's just you call wait for next tick, and that's what causes the timer to start up again.
Okay, yeah. Sorry.
Yeah.
Yeah, you have start counting when you call wait. You have wait will complete immediately if there has been anything, and you have and it needs to play catch up. And then I guess the fourth mode is the wait only completes on a heartbeat, and if you weren't listening when the heart beat, it skips the thing. So those are the 4 different behaviors we've described.
Yeah, 4 sounds very not useful.
So are we thinking enum just so we can add future modes, but we would actually just do 2 by default because that's
I'm actually thinking just 2.
Yeah. So enum?
Yeah,
No,
so
no.
you're saying just do,
I'm saying like,
one mode, which is mode 2. Is that
right, I'm saying the only thing we do is the support for the same thing ASP.NET does today.
Yeah.
Which is the bit gets set while you're not listening, and then it drains immediately on your call to wait.
Exactly. If we want additional modes in the future, it's an extra constructor and enum.
Yeah.
Okay.
And depending on how we choose this, depending on what semantics we choose for stop, you could potentially use stop to implement the first mode if we wanted. Like if we said that wait for next tick async started the timer regardless of whether it had been stopped or not, then you could, the very first thing, if you wanted some first mode, the very first thing you could do after you await is call stop.
Right.
Yeah, I mean, the question then is how would you ever get out of, like, when is it going to return false? When it gets disposed, but you're never disposing it because like I assumed that stop was you could, if the timer was on a field, someone could call stop, and now the next call to wait for next tick async will return false.
That's true, right? If stop is basically transition this thing to never firing again, such that all subsequent wait for next tick asyncs return false, then yeah, it can't be used in that manner.
Yeah.
Yeah. I mean, we could add a pause, but
so I was on the fence about the token versus the stop, or having both. I really think a non-throwing way of stopping it is nice.
right, as a field, it would be nice that you just get to say like, oh, and stop the timer.
Yeah.
And so that just means that if you want I want you to always take half a second from the time I finish this iteration to the time that I start the next one, so that it's measuring down to up instead of up to up. Then we would need another method for that, where pause is the best that I came up with.
Sorry, Jeremy, what would that do?
So if you did while await, wait for next, and then your first line is pause, then that's the soft stop, where wait for next tick async will resume, and now it will measure again 5 seconds in the case of the example on screen. It will now, that would be task.yield 5 seconds.
I see.
So it's I finished this thing, please let 5 seconds of other work happen and then come back to me, as opposed to I want to start this every 5 seconds.
It's possible we're just making this too complicated by talking about trying to enable the additional modes. Maybe we just say it's just that second mode. You want the first one, you just await task.delay, and if we get enough feedback, we add the constructor and an enum or a pause method or whatever.
Yeah, these are the ways that I think that we could grow it.
Yeah, no, I'm summarizing in my head. Well, yeah. Vocally as well. As for the cancellation token versus stop, I think both is fine. I view them largely orthogonally. Like the stop they're different modes of interaction. I think the cancellation token is one where you're trying to tear down a whole bunch of stuff at the same time. You want everything to compose, so you use a cancellation token for that. And the bool is, it's just I want to while await and break out of it kind of like an IEnumerable.
Yep.
Yeah.
So on that, can we scroll to look at the alternative APIs? Because it's worth looking at. This was the original API, but I had trouble because there's no non-generic async enumerable. I think that was the main reason that I went with the async timer pattern instead, and also I could add methods to the async timer instead of like just using async enumerable. But it does make for a very cool pattern here. Except for the underscore looks kind of jank, var underscore in the discard.
If we could come up with something interesting to return to yield, but in the process we end up losing that stop method. Your only method for breaking it out is either something custom that you layer on top or the cancellation token. Would you still prefer the async enumerable?
How do you stop it?
Cancellation token or your own signal layered on top to break out of the body, but you wouldn't be able to break out of the await.
Yeah, so that is why I think I ended up with the token as well. Sorry, the other model as well, the async timer class. I think that's why I prefer it. So maybe.
Yeah, I think that there are a lot of people who could look at the async enumerable and be like, oh, this is clever. Or that they would write it of like, oh, this is clever. But I think that the class gives much better intent and allows for a clean way of doing stopping and discussing the other kinds of behaviors it can have in the future.
I agree.
So I like the class.
And the third one is to put it on timer, but then I think it'd be chaos. So
yeah, I don't like the third one. Just because there's so many things that could be interacting with on timer, and it's not clear. Yeah. Like what do the various methods on timer do when you use that constructor, or what? Yeah. My only concern, like I'm fine with the async timer class. My only concern is, again, not to bike shit, but the name. Like, how does someone know when to use timer versus async timer?
How does anyone know when to use one of our 4 timers today? They don't.
Well, it makes it worse. I mean,
yeah, this problem is one that we, as a like platform, can't really solve without documentation. The one in Go is called ticker, if that helps. We could call it the same thing because it ticks more than once, I guess. But I think we're gonna have this problem even if you call it something that seems reasonable, just because the docs will all point to timer, and then we'll have a new version, M timer, modern timer. I called it async because it was wait for next async, but
yeah, I understand, and I mean it makes sense in isolation.
Yeah.
I wonder if using something like interval or repeated, or I don't know what the common adjective we use here for repeating timers is, but if we include an adjective like that, so it's like async interval timer, that might be a little clearer about specifically what the intent here is.
Or looping timer or timer loop or something.
Periodic
timer might be clear.
I feel like that was the name of the class that I wrote in Office that subtracted the amount of time it did work.
Kind of like periodic timer.
Yep.
Yeah, I kind of like periodic timer too.
Cool. Periodic timer. Ship it.
Did we add a bool or did we say one mode?
I think one mode. And we can add more in the future if necessary.
Perfect.
But like ASP.NET today only has use for that one mode, right?
Yep.
And I don't think anywhere in the core libraries we have this kind of timer loop. Although I guess we might be able to replace some of our uses of periodic timers with this if we wanted to. I don't know that we would, but maybe.
We might have stuff like this in IoT.
Sure.
Periodic timers are fairly common there, and so we might be able to check there if there's anything we can replace.
Okay.
It's interesting because the style of your code changes a little bit. You end up having this async loop kind of hanging, right?
Right. You end up with your favorite async voids.
Oh, no, what? No. Async task, just, yes, void task.
Right. So is there anything that we want to put on it? Is there a useful mode for synchronous code? I don't think there is, other than something that listens to this and fires a callback, which is just the existing timer class, but with avoiding skips. So,
I don't think there's. I'm trying to think if there's anything we could reasonably do in the implementation that would be better if we did it than if somebody else did it. And I think the answer is not really.
Yeah.
So.
All right. We have now considered the synchronous version of an asynchronous method.
David, what threading guarantees did you have over the API? Like which methods do you expect to be able to use concurrently and not?
Stop is the only one that can be used concurrently.
Okay.
Well, so unlimited calls to stop are allowed with one concurrent call to wait.
Yep.
Yeah.
Okay. That seems reasonable.
I had a question about the synchronous thing. So, like, you should just use timer if you don't want to write async code, right? That's the guidance.
Yeah, but then you have to do all the work to avoid the overlapping callbacks.
Yeah. So then, one question would be, would you have?
Well, I mean, I don't know what it means to write synchronous code using timer. Inherently, everything you write with timer is asynchronous.
Yeah,
that's true.
You can have as much synchronous code as you want between your.
You're
waits.
right. Yeah, you're right. You're right.
The same as code that's in the callback.
Yeah,
right.
And again, and somebody who wants the callback version of this, it's easy to write on top of it. You have the while true task that fires your callback.
Right.
I guess the other question is capturing the sync context is tricky to do if you task.run somewhere. So if you try to use it in a place where you cared about the sync context, you'd have to capture it yourself and kind of restore it on the thread doing the work, right?
You mean your async method automatically captures execution context?
So yeah, so that works for the execution context, but if you wanted the callbacks to fire on the sync context.
Oh, sync context.
Yeah, sync context. Then you'd have to like stash it somewhere, task.run, and then restore it to set current before doing the first await.
I guess I'm not understanding. If you wanted all your, like by default, all your callbacks will happen on the caller's sync context.
Well, so typically to use this API, the pattern you have to use. So let's say you're in a WinForms app, right?
Sure.
You have to create it somewhere, stash it in a field, and then task.run. You can't. Well, I guess you could do it inline, but it would be kind of weird, right? So you would task.run, and that doesn't capture the sync context.
Sorry, do you want the code in the method to run on the sync context, or you want it to not run on the calling sync context?
I think it depends on your scenario. So for example, like dispatcher timer in WPF does run it on the dispatcher, right?
Right. So does Windows Forms timer.
Right. So if you wanted to get the same effect, you would basically have to do the storing of the sync context, the task.run, and the restoring of it.
No, the storing of the sync context happens automatically.
Yeah, await does that for you.
No, okay, so it does, but only if you start on that thread that had the sync context.
Right. So your loop is an async task returning method. You just call that from your UI thread.
Right. So I think that is less idiomatic because this pattern forces you to task.run. Doesn't force you. You end up task.running and starting the timer on a background thread.
I don't understand why that is.
To start the timer, you could.
Someone clicks the button.
Yep.
And in my button click handler, I call my method start timer, which is an async method that enters an await loop.
Say you had a clock function, right? And every tick of this timer, you want to update the UI.
Yeah.
Right. I would have to write an async method, and I would call it directly from my UI thread, right? That would work.
Yes.
That works fine, but I think people end up task.running long-running async methods but just by habit, by pattern, right? To offload from the current thread. Even though the first await would yield that code, I think people end up task.running just by habit. And you would lose the sync context as a result.
I mean, then you use whatever means you would normally do from your your timer or your other async code to get back to the UI thread.
Right.
Or just use async void.
Right. I guess.
Void, yeah.
I guess I'm struggling to understand. I think what you're saying is the problem is people are going to write code that more complicated code because they think they have to, and that more complicated code is going to make them write further complicated code to do what they should have just been doing in the first place.
Yeah. Yeah.
I think that's an education issue.
It is, but like I think we should recognize that when we design these APIs, it leads people to patterns that even if they're incorrect, may be the most natural thing to do.
I mean, so with timer today, someone's already going to have to get back to the UI thread, and
that's a problem. And I think like the async version actually makes it easier because async await handles the sync context for you automatically. But I think it leads to the task.run thing leads to a pattern where you lose the sync context, right?
What are you suggesting? Is this your way of suggesting we start adding awaitable things that bring you back to the UI thread?
Well, maybe there should be an API to kind of start a task, but preserve the sync context.
Yeah, so something like task.run in current sync context.
Yeah.
Is that what you're saying, David?
Yeah.
Yeah, I can see that. I can see how that would be useful.
So, okay. I mean, that exists. It's just not as succinct as what you just said.
Yeah. Yeah.
When you say it exists, what does it look like? Is it a flag on task.start or something like that?
Task Factory Start New takes a task scheduler, and you can say task scheduler.get from current synchronization context.
Okay, makes sense.
I mean, can I ask a different question?
Fixed, but I guess I don't. I'm struggling to understand how that would, like, what what does it mean to task.run to the current synchronization context? Is that not just synchronization context.post?
Yes, it is.
Yeah, which is never a method that would occur to me to call.
I just think people don't, like, if you look at the code people end up writing, when you're kind of trying to do a thing in the background, but you have to kind of start it from your current synchronous code, task.run is your natural go-to for kind of like, start this thing over here and let me continue. People rarely call the method and let it yield asynchronously, just because like maybe it may end up blocking the current thread for longer than needed. Like imagine the first tick fired and it ran on the UI thread and you didn't want that. Your first reaction to fix it is to task.run, and then you've lost the same context. And it isn't a thing we can just solve. It's more like, should we have a pattern, because this will become more common once we add more async APIs? Kind of suggestion.
I think.
I don't. Sorry, go ahead, Jeff.
Well, I think there's also an issue of you were saying people do task.run instead of just invoking an async method and letting it yield. I think that's true, and I also think like part of it is just a mental model thing, right? It's easier to think of me kicking off a background task, and then it's going to somehow magically, according to the right rules, execute in the background of whatever context I want it to, as opposed to this kind of implicit thing where you sort of invoke an async, but then you don't care about the task that it returns, and then it's sort of like, well, it's a messier model, I think, for people. They don't think about it that way.
So I suggest someone who cares, who thinks there's a problem here, opens a new issue, since we're no longer talking about this API anymore.
Yeah, sure.
Also, like, I'm still struggling why, if I'm building a UI app, why would I use this new timer? Why would I not just use the existing timers that are effectively already designed for the UI stacks? Because, I mean, it seems like if I would consume this timer, I would most likely do it indirectly by some other API, in which case that other API happens to use the timer under the covers, and if that other component happens to be optimized for the UI, it will take care of, calling callbacks on the UI thread.
I guess so. We shouldn't, I guess, spend more time on it, but I guess the last point is, that's true, Emo, like, and we have dispatcher timer and the WinForm timer. But I think like .NET basically did a good job of abstracting the whole sync context thing with async await, and that pattern is, I think, easier to grok than having to do dispatcher dot whatever. But I could be wrong. I don't know.
Well, it depends on how you use it, right? I mean, the idiomatic use of these timers is not to call methods, right? The idiomatic use is you instantiate them and then you subscribe to an event, and that one is called in some interval, right? And so by the time you're running, you're already on the UI thread, so you don't have to task.run to offload it, and you also don't have to do anything. And then within that thing, if you want to do something asynchronously, well, then you do whatever you do normally in WinForms, right?
But it has all the other issues, right? Of like overlapping calls and like the same issues that this is solving. Those timers might have. I'm not sure. And my only point was like, there's what the timer solves, and there's how you get back on the right thread once the timer fires to do work.
Yeah, I mean, to Stephen's point, right? I'm still somewhat at loss what you think idiomatic code in the UI looks like, because I think I buy the argument that if you want to do something that is potentially, involving a wait that might be expensive, and you go back and forth, people might task run that. But the people who do that, they kind of know, because if you try task.run and, then you do something crazy, like you might end up getting exceptions anyway, because you're now, continuing on the wrong UI thread, right? Or not on the UI thread, right? So that means if people do something, out of the ordinary, like they already kind of off the rails in terms of what we do, right? The normal idiomatic way is you have a button, it's a void returning method. You want to do something asynchronous, you put async on the event handler, you write your code, and then you cross your fingers that nothing bad happens, right? And that's probably what 90% of people do in WinForms, or WPF for that matter. Or you're doing something backend related, in which case, somebody else encapsulates this thing, makes it UI nicely, and then has some events that automatically run on the UI to it, so that you can wire it up without breaking your fingers. Like I'm somewhat like, I'm not trying to say like this is not used from the UI. I just don't think it's an API that idiomatically would be very commonly used in the UI.
Maybe.
So that doesn't have the same context, right?
Yeah, I'm fine skipping it.
So I think what we have right now, as far as I can tell, is we have this API still as proposed, right? Have we made any changes to it?
Okay, can you scroll up to start the API surface again?
Yeah, and what's the namespace?
I think system threading, where timer already lives.
What's the return bool on wait for next tick async?
Has stop not been called?
Right.
So it returns true until it returns false, is that it?
Yep. It returns false when it will never fire again.
Yep.
And so is the idea, if you want to resume it, you have to destroy it and create a new one?
You can't resume it.
Right, so you have to create a new timer when you do that.
Yeah.
What is the dispose async implementation do?
You mean overstop?
Or in general, what is it waiting for?
I just copied whatever timer had. I assume it waits for the timer to keep. Actually, I guess.
So the problem with timer is because timer is firing callbacks.
Yeah, I get it.
It needs to wait for them.
So
yeah, I don't think it needs to be async disposable.
Okay.
What's the difference between stop and dispose?
I knew this was gonna come. so stop is called by. Okay, so stop says stop the loop, and the loop removes itself from the timer queue. So dispose is like delete from the queue, and stop is stop the loop from running.
Yeah, I guess the idea is that whoever calls wait for next tick async is the party that calls dispose, but somebody else will call stop, right?
Yep.
Yeah, stop is stop. Basically, make anybody who's waiting on this timer see false and exit their work, and then dispose is held one time by someone at a bigger context.
Right. I mean, technically you could make dispose do there, but it seems very rude to call dispose on somebody else's component.
Right.
Yeah, I think it looks good as is.
Did we close on a class name?
Oh, I think we changed it to periodic timer.
That sounds good to me.
Sorry, I lost audio for about 30 seconds. What's the behavior if you dispose without calling stop? Someone who's in wait for next tick async wakes up, or is that an error?
Well, I think the wait for next async will throw an object this bullet exception, which is bad. Yeah.
Okay.
That.
Yeah, an ODE will leak out somewhere.
Got it.
Don't do it.
And so are we still async disposal, or are we just disposable?
Just disposable.
Just disposable.
That's what I thought. And then I think the other thing we said is there's like 3 theoretical modes, and we said we only need one of them, and I think the one we said we want to have is the one should complete immediately for each period that was missed, but only once, right? It wouldn't fire for every single period that was missed.
Right. In Tanner's nomenclature, it's the auto reset.
Okay. Logically, it's the ready bit gets set on the timer, and calling wait clears the ready bit. Or calling wait returns when the ready bit is set.
Okay. So I just pasted what I have in the notes and what API should we just talked about.
We probably want to rename the constructor to match the type so it compiles.
Seems like a reasonable thing, yeah.
Very nitpicky.
I have often wished that C#, the language, allowed what we just call it in IL, and you just named it .ctor. That way you could copy and paste with, more easily. But yeah, whatever.
If only we had primary constructors.
Should cancellation token be defaulted?
Yes.
Yes.
All right.
Beautiful.
Ship it.
Beautiful.
All right. Wow. 3 controversial ones down. Then I think we can go in the order that we had. If the window ever comes back. Oh yeah, so this one we closed on. I think Laomi is the one that is marked this one, right? Or was it Eric?
Thank you. Can you scroll to the top, please?
Yep, I am.
Thank you. Okay. So this proposal is about adding methods to provide ref access to dictionary values. So motivation for this is to provide a mechanism that avoids duplicate hash key lookups when obtaining dictionary values which will not be present, and add a value if it's not. So this is the get or add pattern that we have in concurrent dictionary. So that's one motivation here. And the other motivation is to provide a mechanism which avoids copies
API
and
usages.
duplicate lookups when accessing struct values in dictionaries. So for today, both of those patterns require like double lookups. And in case of structs, it's copied when you're trying to get the value. So the 3 methods proposed are on collections Marshall, which is a unsafe class that provides methods to access like data representations of collections. So the first one, and they differ in terms of how they respond when the key is not found in dictionary. So the first one here, can you scroll just a little bit so I can see my notes? Imo, scroll up the other way.
Oh, sorry.
LLY
Sorry.
update is struct in a scenario.
Yeah, so
Public mind get.
okay. So now I'm at the
Public
API
mind
proposal section. The upper part is just like background reading. Sorry. So just a little down. I can look here, but just so we're all on the same page. Okay, so yeah, the first one, get value, you pass the key, and then it throws a key not found exception if the key is not in dictionary. The next one, try get value ref. So this one will return an out boolean to see if it exists or not. If it's not in dictionary, and we'll return unsafe.nullref if the key isn't in there. And then the last one, get value ref or add default, will add a default instance of the object if it's not present in the dictionary, and also return an out boolean exists if the value was in dictionary. So we can scroll down to some of the API usages. But before I move on, are there any questions so far about motivation and things like that?
Just one question, though it overlaps with the API usage. They're not defined as extension methods, which I assume is by design, but they're being used as extensions in these API uses, which is correct?
Yeah, that's correct. They're not extension methods. With extension methods, we'll be able to provide the same sort of pattern for get or add, but it wouldn't be any more performant because we don't have access to non-public surface area. But that was considered as well. I'll talk about that later on. Here.
And we don't want extension methods here because it's unsafe.
Right. So I was just highlighting that the API usage has been stale. It needs to be updated.
Right. Because it should be collection marshal.getValueRef dictionary key instead of dictionary.getValueRef key.
Got it.
Have we added tries for ref return before? Because I think this will be the first try that's not Boolean returning, which means we shouldn't do it.
We've not done it because it requires you to use unsafe is null ref, but given that this is a performance-oriented API, it is itself unsafe, and you are likely using unsafe tricks with it. I think that returning it is better for the scenario.
I'm just really my iffiness on it is that now we have the try pattern and the ref return try pattern, and I would like to avoid two patterns if we can.
What's the reason for not just for getting rid of try get value ref and having just an out bool on get value ref? Is it that much more overhead that we're concerned it's going to impact that fast path, or like why have one that throws an exception at all? Yeah,
I'd argue it's perhaps not necessary to have one that throws the exception. I guess it was just options as far as like what the possibilities are about the usage patterns. Maybe there's some scenarios where you want an exception, but that has some costs, so it's probably not the best. I
mean, we could certainly do it as get value ref key and get value ref key out bool exists, and the one that doesn't out bool exist throws the exception. Like it just wraps the if not exists throw for you.
Yeah.
Basically, it's get rid of try on the middle one. It's
that's
try.
fine.
You're getting the bucket, and it tells you there was no bucket.
Right.
Right.
Yeah, I think the exception throwing one makes sense to me because most of the time you probably know that the key should be in there, and if it's not, like something catastrophically went wrong, so you just don't want to write the catch clause, right? So I can see the value.
Yeah, I mean, I imagine there are scenarios like that, which, I mean, that's how I categorize it in the usages. There's some cases where you expect the key to be there and it's an exception state. It's just the value, it's just a question of how often that happens and if that's like a primary scenario. I think from the discussions, most people are leaning toward the last one as like what is desired, like especially in the struct case. Just create default and then I can modify it. But I think generally for like any one of these like overloads or even the new pattern described can satisfy the scenario. So there's an opportunity to like revisit and add other variants if we need to.
Have we considered like basically a method that would accept the delegate and the delegate gets the underlying graph? In which case it probably would be safer, I guess.
I mean, the point of these APIs are to avoid allocations, reduce copying. They're for extremely performance-oriented places where you basically want a span, but can't get a span. So I don't think we want to do delegate or anything else that can add those overheads, because when you get down to cases like these, like just like where we added list as span,
right,
you are likely close to counting cycles for some of your algorithms.
Sorry, what allocations are we avoiding?
Immo just suggested a delegate.
Oh,
yeah.
No, but you said the purpose of these APIs is avoiding allocations.
Right. If you want to do the if you want to operate on this without having a ref returning function, and you want it to avoid allocations, the current best case approach is to copy the underlying value collection to an array.
Oh, I see. Sure.
Yeah, can you scroll back up to the proposal, Emo?
Was it find my browser window again?
Yep. Right. So the last one is, I want this bucket to exist, but tell me if you just had to initialize it. And then the other two, if we just get rid of the try on the middle one, like get rid of the word try, but keep the method as described. Those are, give me the thing, but don't allocate, like don't cause any sort of rebucketing to happen if it's not there.
Yes, that would be.
Yeah,
that should be.
So, I do think that we shouldn't just add the last one, because you've modified it while asking a question. I think if we just get rid of the word try off of try get value ref, then is okay.
I think the try is important there because it's indicated. So the proposal here isn't actually, it's what Eric had put minus the comment that I had followed up with afterwards, in that there shouldn't be an out bool exists on the middle one. You detect exists or not based on if it's null ref. One, yes, for performance reasons, and two, because that's how you can. That's how we're going to internally have to return if it's not there. So you don't actually need the bool exists.
That makes sense to me.
Yep,
Meaning you don't have the throwing one at all. You just have the top one, which returns null.
No. You explicitly have the one that throws, and then the try that returns a null ref. There's other places in .NET, not necessarily in the BCL, but other places where the try pattern does not return bool. It returns, for example, a class where null does not exist. It's a try pattern that does exist in the ecosystem and that does occur, especially in performance-oriented code.
Do we have any of those?
I'm not sure if we ourselves have them, but I don't think this is too far of a concept from try-get.
from a patterns purity perspective, I definitely would prefer that we not use the word try. Whether it be it just is an I'm doing a thing and you have to measure my output, or that we come up with a word that's not try.
Yeah, I mean, it almost feels like it should be unsafe get value ref if we have to compare against unsafe null ref.
Concurrent set, well, it's internal, but it has try get, which returns an item type, which is nullable.
Internal doesn't matter.
It's still a concept that .NET uses. I don't think it's a purity thing at all. It's .NET uses this concept where it's appropriate, because the nullable information is representable by null.
I don't know. I agree with Jeremy that from a patterns perspective, a code developer wrote internally that's non-public, that never has to follow public API guidelines. So using that then to set precedent is strange. That said, I have a fairly low concern in this case.
Yeah, I mean, I kind of agree with that, because the thing is, it's on collection marshal. It's not an extension method. It's in the interval services namespace. So, I mean, I can go with almost anything. I'm even okay with, going try get value ref, or we can go get value ref or null ref. Like, I don't think it matters realistically.
Yeah, I'm really just concerned that I'm aware that the ecosystem sometimes uses try for, if I return null, that meant it failed, but that we do have our guidelines, and the guidelines we have, everything that talks about a try is a bool returning emitter. And I'm concerned of, well, we have this niche reason that we're breaking it here, and then now we have this other reason that we're going to copy from this in a less niche case, and then eventually the pattern sort of loses meaning. And that's what I'm trying to defend against.
It's also a case where I would argue that us returning bool for reference types is wrong and not performant, and if we could go back and change it, I would have argued, and I wasn't 8 years old at the time, I would have argued we should have had anything that returns a reference type return T, and the try pattern probably should have returned nullable instead.
My understanding on that is Anders was fundamentally opposed to that, because it didn't, if you had a dictionary where null was a legal value, you don't know if you got null because it was in the dictionary or because it wasn't present.
Right.
And that's why he invented the pattern the way it was.
For certain cases, that's definitely the case. But in other cases like this, where you know that the key, therefore it is null or not, and you're returning, for example, a ref, then you fundamentally want the optimization. Modern languages do reification and erasure so that optional types and option of T for reference types becomes null, because it's more efficient and makes the code faster. And it's generally a compiler optimization in modern cases.
Yeah,
so the decision to use try in the way it's used isn't about performance. It's about usability, right? To be able to write if try get value, then do something with the value. That's
right. And then for C# that works fine, but F#, for example, rewrites every single .NET try thing to be option of T internally, so that way they work with their own patterns.
That's fine. But how much code in the world is written using C# versus F#?
Right, but the concept that I'm arguing for here is that the pattern exists because of a C# limitation from 20 years ago. And if we had a modern perspective on it, and
I'm saying it's not a limitation.
Yeah, I think to just pop up, right? So, I mean, it doesn't really matter what the better concept would have been 20 years ago, because, the problem is we shipped that pattern 20 years ago, and that's used pervasively, right? So now the argument is more, what is more consistent, right? And we're arguing for consistency because it's less cognitive load, right? So I'm inclined to agree with Tanner that, optional of T is probably a better way to model some of the stuff, but we also didn't have nullable reference types at the time, right? So there's many things we couldn't have done in any sensible way. But the thing is, now that we have the pattern, like I kind of agree with Jeremy that try is not the best prefix here, but like I can live with the general idea, which is you take a dictionary, you take a key, and you return another ref, and it's not found. So now we're just arguing what the best name is, right?
Right, and so I think if we look at get value ref is throwing, get value or add default is potentially modifying, then the middle one is get value or null ref.
Yeah, that or I mean even unsafe get value ref would work for me as well, as I think Steven suggested. Like I mean.
Yeah, I'm just opposed to the word try. We have a pattern, and if we want a new pattern, it needs a new name.
I like get value or null ref. For a couple reasons. One, it's very clearly saying what it's doing. Two, it avoids the try issue. Three, it tells you exactly what you need to compare to, unsafe.nullref. Four, it matches with the or in the next method, so it's consistent with that. And five, it matches with what Link uses, first or default, that sort of thing. So that one makes sense to me.
I'd be fine with it as well. I just don't agree that the try pattern is bad here.
That's fine. We can agree to disagree. All right.
So would that be get value ref or null ref or get value or null ref?
I would say get value ref or null ref. But
yep.
I'm okay either way. If I were proposing it, I would have recycled the word ref, but get value ref or null ref.
I think for a variety of reasons, including consistency with the other methods.
Yep.
Yeah, I like this prefix more than avoiding the double ref.
Just to confirm, so we're also dropping the exists out here as well.
Yes.
Because again, okay, cool.
But only on the second one, right? On the last one, we still keep it in, right?
Yeah, we need it there.
Yeah. The last one is telling you whether you hit the add case.
Yep. For sure. I guess, I just have some other notes here, but if there's no concerns, I don't know.
The only other, this is total nitpicking, but the name for the last one, you are always getting the value ref. It may be that it first added a default.
That is true.
The names were picked to mirror the existing dictionary names, hence get value ref instead of get value, try get value ref instead of try get value, and get value or get value ref or add default instead of get value or add default.
The dictionary doesn't have get value or add default, does it?
I think we edited it on collection utils or something. I think it's an extension method, but I believe we have it.
Could we just call it get or add value ref? I mean, we're removing the default part from the method name, but I think that should be obvious from the documentation, I suppose.
And the fact it didn't take a value.
Yep.
I guess the existing ones get value or default, not get value or add default.
Yeah, that's right. So we have get value or default, which which makes sense. But you either get the value or get the default. Versus the last one, yeah, it is a bit weird to say get value ref or add default, but
I mean, in link first or default doesn't imply any modifications taking place. It just returns default.
I mean,
so
if we wanted to be
important here.
Clear, it's really it's get or add value ref, or I guess get or create value ref. I don't know, because get or add / get or create is what we're really doing, and then you get the value ref. But
yeah,
I think Steve had a reasonable name somewhere in the middle here.
Yeah, can somebody repeat that?
Get or add value ref.
Sorry, you need to say this slowly.
Well, that was the one I said that I don't know that I like, but.
So what was that? Get
or add value ref.
Get or add value ref. I mean, the only thing I don't like about it is it doesn't make it clear what the value is. The other one says add default, but I guess that's fine.
Yeah, I mean, I think the current name is fine, also because it keeps it aligned with the other two.
A saving grace for anything on here is it's buried in system runtime interop services collection Marshall using ref returns and refs in the name. Anyone using these methods needs to read the docs.
Yeah. But I think looking at it you would get the IntelliSense grouping of get value ref or null ref, and get value ref or add default. And then you look and you're like, oh, I see it. Adds default to the default of to value to the dictionary under the key and gives me the ref to that and tells me whether or not it had to do that extra work. Okay.
I'm
it's
inclined
not
to
a
agree with
perfect
that.
name, but I think it's pretty good.
To me, the ordering or grouping is, I think, much more useful than the more accurate name, I guess.
While we're on dictionary, and since it sounds like we finally stabilized, sorted dictionary also exists and is in the same boat, basically. Do we just want to mirror these APIs for sorted dictionary?
That seems problematic. Doesn't sorted dictionary change ordering?
Sort based on the key, not the value. This returns the value.
I see.
It's the same reason why we can't do this on hash set, because hash set uses the value for the key, but it's fine for dictionary because the key and value are separate.
Has anyone asked for this on sorted dictionary? No,
but we've over the past 6 months we've added the one for list. We've added the safe overload to linked list node. We're now adding it for dictionary, and of the remaining types, there's sorted dictionary, sorted list, stack and queue that could benefit from the same.
Yeah, I'm just saying we shouldn't proactively go and do this complicated API on a whole bunch of types just because we can.
It's not complicated, it's just additional surface, but
it's
I know
complicated conceptually.
Potentially. But I know at least for stack and queue, I have my own needs for ref returns. I imagine someone else may have the same for sorted dictionary if they're already doing it for dictionary.
Yeah, let's approve this one here for now, and then we can, if we ever need it for the other one, it's slam dunk, we just do it. But I'm kind of inclined to agree with Stephen, because the problem is we have so many collection types and becomes...
Yeah, and I mean, the good news is if we decide to add sorted dictionary later, it's just overloading these three things. But I think we should wait until hearing why someone who wants to do this also wants to use sorted dictionary. To then justify, because it's it's not just new surface area. It has to go poke around in the innards of the type. So we have to do work on each type uniquely.
I actually don't think we do in any of the cases. Just like with list, the array is already internal. And so it's basically just returning the ref directly.
Well, but the or add has to go do work. And on sorted dictionary, it has to go resort things. However it does that.
Okay, yeah, fair.
The peaking of just getting the value ref is probably we could easily add it if we wanted to. The get or add is specifically the one that makes me think we would hold back on sorted dictionary until we had a justified use case.
That's fair.
All right, then let's get this one in. And then I think we're out of time for the rest. But it's pretty good.
Thank you.
Thanks.
All right, then I'm saying thanks, everyone. And then I see you, I guess, next week.
Thanks all.
Ciao.
Bye-bye.